good to start.
It's already been going,
Are
mate.
you going?
Yeah, Emma's just started it.
Okay, so this whole rearranging thing is the idea of changing around what the equation equals to help us solve equations to find like what we need to find from what the problem is asking us. In other words, like we're looking at F net equals MA. At the moment it's force equals something, but we might want to change that to make it mass equals or acceleration equals, like M equals or A equals. So we're trying to build up the skills to do that. That's the idea. And there's a few useful ideas. We're going to add one more to this list in a second. First thing is, we always do the same on both sides of the equal sign. It's what they always tell you to do in maths, and as you get better and better, you might get a little bit more casual at it, but whenever things start going wrong, always come back to doing the same on both sides of the equal sign, and things will always work out. And think about our operations kind of like as opposites. Like the opposite to plus is minus, and the opposite to minus is plus. Times versus divide, and squared versus square root. If we kind of think about it like that, we can use those to undo things and redo things on our equations to change them around to make them equal to what we want. So let's have a look as an example at this F equals MA. And say we were trying to make it into an A equals. The question we ask ourselves is, if we want to separate off that A, we're going to have to move the M away from it. What's the operation that's connecting the M up to the A? It's a times. We don't write it A, but there's an invisible little time sign that sits in there. We come down to our opposites, like what's the opposite to times? Divide by, always do the same thing on both sides of the equation. Divide by M, we're trying to get rid of the M and leave the A. Divide by M. And so, look, the top one and the bottom one just cancel, and we're left with A equals F net over M. So then we get down to speed is change in distance over change in time, and we use the little delta, the little triangle. That means change in velocity is change in distance over change in time. And say we're trying to rearrange that to make it equal to distance. How's the distance connected to the time? We're going to get rid of the time. How are we going to get rid of that divide by t? What do you think?
Times the left side by that triangle t.
Times delta t times delta t. Cancel, cancel. And we're left with speed times change in time is equal to change in distance. What about though, what about if we had been trying to go the other way? What about if we needed to know the time? That's a real problem, because that's on the bottom of the equation. We hate stuff that's on the bottom of the equation. It's no good. What can we do about that? Times it. Let's do one thing at a time first. So times it, times by change in t, times by change in t. So we get to that same place. Speed times change in t is equal to change in d. And we're trying to get the t by itself. How do we take away the v? Divide. Good. So divide by v, divide by v, cancel, cancel, and we're left with change in time is change in distance over speed. That brings us to the third and final little useful idea, and this one's like a cheat. Did you notice that all we did was, what I think they call drop in swap. So when you've got one thing equals a fraction, it does work to just swap out that bottom number from the fraction with the thing out the front, and you can just do that little flipperoo there. That's like a little cheat. Let's have a go at something. energy, half times mass times speed squared. And we're going to have a go at, first of all, we're going to aim to make it M equals, and then we're going to have a go at making it V equals. So if we're trying to make it, this is as hard as it gets, this is it. Once you can do this, you can do anything. Oh, cool. So, I'll just write it out again. EK equals half mv squared. And cool, that's a really elegant way of dealing with it, is instead of looking at that half and trying to do divide by half. Dividing by half starts getting ugly because you're dividing by a fraction, and a fraction is already divided by. So, we don't do that. Instead, get rid of a half, times by 2. So, times 2 times 2. And we can rewrite that as 2 EK is mv squared. What are we going to do to get rid of that v squared?
Square root.
How's it connected to the m?
Divided by v squared.
Times. So we're going to divide v squared, divide v squared, and we're going to go cancel, cancel, and we end up with m equals 2 EK over V squared. Last one. How do we make it V equals? Starting with EK is half mv squared. What's the first thing we're going to get rid of? The half, we're going to get rid of it by times 2. Cancel. So 2 EK is mv squared. What are we going to do next? Divide by m. So we've got 2 EK over m is equal to v squared, and then
And you square root 2EK over M.
we can square root both sides, and I'll rewrite it the other way around, that v is equal to the square root of 2 EK over m. And that's really nice, because once we can do these rearranging, once we've got this rearranging skill on lockdown, we can take any of those 8 equations that we get on our formula sheet for our topic and rearrange to solve any problem in the exam. So that's kind of like put some really nice limits around. There's 8 equations we have to be able to rearrange. That's it.